Hi, and welcome to Quantum Mechanics Revision 3 Feynman diagrams. So, there are 4 Feynman diagrams that you need to be able to do for the A-level, and you should by this point be able to just snap them off without even thinking. So, I want you to pause the video and actually do that. Actually, factually pause it and try drawing all 4. You'll get so much more out of this video if you have a go first. Go on! Okay, let's have a look at them. So what I'm going to take you through here is just my thought process if I was in an exam and I was unsure about how to do one of these 4. Okay? I'm doing so hopefully it'll make it a lot easier, make the remembering a lot easier. So, beta minus decay. So what do I know is going to happen? Well, an electron has to be ejected out of the atom. That's what beta minus decay means at the end of it, doesn't it? So we know we're going to be finishing with an electron. Now, electrons negatively charged, which means you either had to start with something negatively charged or start with something neutral that turned into something positively charged, so overall everything stayed neutral. So there are 2 options. There's nothing really we could start that was negative inside an atom. We've only got protons and neutrons. So we must have started with a neutron and ended with a proton. So a neutron's going to come up here and turned into a proton, and then our charges are going to work. So we're going to have some exchange particle, just going to ignore that for now. And then we know it's going to emit an electron. So do our charges work? We've got no charge before here, positive charge, negative charge. Yes, the charges work. Now, before we look at the exchange particle, I've just got to do a quick check. Do I need to add a neutrino to make the lepton numbers work? So beforehand, we've got an electron-lepton number of 0 because all we've got is a neutron. Afterwards, the electron is actually giving us an electron-lepton number of 1, so we're going to have to add in an anti-electron neutrino in order to cancel that out. Okay, so now we've got basically everything. All we need to do now is work out what our exchange particle is going to be. If you remember how I told you to do this, it was to look at the vertices. So no charge is going into this, a positive is coming out one side, so therefore we're going to need negative coming out the other. Because then positive, negative is going to equal our charge. Brilliant, negative charge comes over here, what comes out the other side? Negative charge, chargeless. That all works, bada boom, bada bing, beta minus. Great. Moving over to beta plus. Well, we can probably, now that we've got our beta minus, do this pretty quickly, because I suspect it's probably going to be a proton going into a neutron with a positron coming out and an electron neutrino. Let's see if that works. Positive before, positive afterwards. Electron-lepton number is 0 before, -1 plus 1, 0 afterwards. So everything works. All we've got to do is exchange particle, positive going into here, negative coming out. So we want positive out, positive going into here, positive coming out. Everything works. Easy. It's almost as if they're the opposite of each other. Now it gets slightly more interesting with electron capture. So electron capture means the electron is going into the nucleus and binding with something. So it's either got to bind with a proton or a neutron. If it binded with a neutron, you'd end up with a negative particle in the nucleus, and we know they don't exist, so therefore it must bind with a proton. So therefore we know that we've got a proton going in and an electron. So those two are going to go in, and then something's going to come out, and there's going to be some sort of exchange particle. Well, if a proton and an electron bash together, we know that a neutron is going to come out. And that would also make sense from a charge point of view, because we've got a positive charge and a negative charge here, so we need a negative charge coming out. So the only thing we need to think about now, because our charges work, is our lepton numbers. Beforehand, we've got an electron-lepton number of 1, so afterwards we also want an electron-lepton number of 1, so therefore we're just going to need bog standard electron neutrino. Now we need this exchange particle. Again, look at the vertices, what's going into here, positive in, neutral out, so therefore this must be positive, positive in, negative in, therefore this must be neutral, which it is. Huzzah! Finally, proton-proton interaction. 2 protons fly through space and repel. Oh no! So proton number 1 goes like that, proton number 2 goes like that. So all we have to do is remember. Can you remember what the exchange particle is for the electromagnetic force? Of course, a virtual photon with the symbol gamma. Easy. So there you go. There are your 4 Feynman diagrams. If you cannot produce them with your eyes closed at this point, I recommend you practice. because they're really important and they're also just such easy marks. Do you know how infrequently you get easy marks on a physics A level? Take them! Take these marks! Okay, great. There's a question about this underneath. I'll see you tomorrow.